Welcome back, everyone. I'm Stephen Foskett, your host for AI Field Day, and we are underway now. We are here with our second presentation of the event. We are excited to have our friends from Netapp joining us here for AI Field Day. Now, Netapp is a company that's probably pretty familiar to many of the people across the varied Tech Field Day worlds, the realms, as it were, the multiverse of Tech Field Day. We certainly have seen Netapp at Storage Field Day, but also at regular Tech Field Day, Cloud Field Day. Excited to hear what they have to say here at AI Field Day. If you'd like to join the conversation, please do join us on Twitter. Use hashtag AIFD3. You can also find these presentations on our LinkedIn. Just go to Tech Field Day on LinkedIn. Give us a follow, and you'll see presentations like this one all throughout this week from AI Field Day. And as a special added bonus, if you miss any of the sessions, you'll be able to watch the live recordings right there on LinkedIn at any time on demand. But we will be posting these as well to our YouTube channel. Just go to YouTube/TechFieldDay. Join 42,000 of my favorite friends who have already subscribed to the Tech Field Day YouTube channel, and give yourself a video. There you will see Netapp presentations dating back to the dark ages of 2009, 2010, when we first saw them, and all the way through today. So thanks for joining us. I'm going to step out of the way and turn it over to Netapp. Go ahead.
Thanks very much. Thanks, everybody. Welcome. Thanks for coming. My name is David Arnett. I'm a principal technical marketing engineer with Netapp's AI solutions team, focused on AI and machine learning and deep learning, and to some extent HPC as well. I just want to give a little background for anybody who's not familiar with Netapp. Netapp has obviously been a big player in enterprise IT for many, many years. We've been involved in the IT space for almost, the AI space now for almost about 5 years. We've produced several hundred documents. We've got probably 30 or 40 dedicated staff members between engineering and business development and sales who are focused on AI, and they're all out there assisting the rest of our field teams to bring these messages to customers. We've got somewhere north of 300 customers, several in the Fortune 500 and even a couple in the Fortune 100. So this is a space we've been playing in for quite some time now. And even as a company, we're seeing kind of significant growth in this space just for Netapp alone. So with that said, I'm going to go ahead and get started. The first thing I want to do is get my clicker mouse working, and we will take a look at an example here, right? We're talking about AI, and the data science here is very important here, but the scale of the data is what really becomes a critical factor here, right? This is a fun graphic I've shown a few times that really shows the potential scale we're talking about right here, right? Cars on the road may collect as much as a terabyte an hour of data. You could have hundreds or we potentially talk about millions of cars on the road collecting data. That maybe seem a little far-fetched, but when you consider that anybody who's got a Tesla is sending data back to Tesla that they're using to train their models for the next generation. So the number of 1 million cars out there collecting data is actually not that far-fetched. I think the actual capacity numbers are a little bit high. A terabyte an hour is maybe what the cars are collecting raw. But what's interesting to me is this is one of the spaces where AI is actually helping with the development of AI, meaning all of the vendors who are doing this kind of autonomous vehicle development are actually developing models to help them sift through all that raw data, so they don't actually have to save all of it. They only save the bits that are interesting and important. But at the end of the day, we're talking about exabytes of data, right? The actual raw data numbers turn into massive quantities. Over time, that becomes even bigger. And because of the nature of some of the things we're talking about, there are definitely some kind of regulatory compliance issues here. So a lot of this data is going to have to be saved for longer periods of time than might otherwise be saved, or saved for longer than any other data of this kind has been saved before. So the challenges around the data is really where this is becoming an issue in terms of the overall process of the AI software development. So over the next hour and a half or so, I'm hoping we're going to show you how our solutions go beyond just like raw performance numbers, right? There's a lot of talk about speeds and feeds in this space, but at the end of the day, that's not the whole story. There are some kind of minimum performance requirements in order to even play in the game, right? There's some table stakes to get here, but it's the other parts of this, the processes and the management of the whole thing that really kind of help determine success or failure for companies trying to go down this road. So I'm going to start with my colleagues Max and Mike Oglesby, who Max is one of our field engineers, AI specialists in the field, was working as a data scientist before he came to work at Netapp. And Mike Oglesby is the owner of our data ops toolkits. They're going to talk more about how the data scientists can really directly leverage some of the features and capabilities to help make the development process faster and more compliant without actually knowing anything about storage. Then I'm going to spend a few minutes talking about the actual infrastructure solutions that all of this is based on, and really kind of focus more on kind of the IT engineer's perspective, right? What does it take to be an IT engineer supporting these workloads? And then we're going to get a few minutes from our friend at Nvidia, Adam Tettleman, who's going to talk about the DGX Foundry and Base Command solution that is a joint partnership between Netapp and Nvidia. So with that, I'm going to hand off to Max, if you guys will give us a quick introduction.
Hi, my name is Max Amandi. I'm a solution engineer and AI specialist out of the Munich, Germany office of Netapp. In my role as an AI specialist, we get involved as soon as 1 hour of our account managers or solution engineers spots an AI or ML workload at one of our customers. We even try to talk directly to the data scientists and data engineers to understand what are the challenges and how can we as Netapp help them for the AI journey. And I think we all know, or especially from my perspective, working as a data scientist before, that the data science tech language and the IT infrastructure tech language are actually quite different. Because I think it's really important to understand both languages to be able to help the data scientists and data engineers with their problems. And we get involved in quite many different companies in different stages of AI journey. But although the challenges, although we are at different stages of AI journey and working on different problems, we see that they have the same challenges they're facing. And yes, as Netapp, we might be biased, but we see usually the bias or the biggest problem regarding the data. In the beginning of the AI journey, we tend to see the challenge regarding data access and data availability. The best data scientist cannot build a good model if he does not have access to the correct data. Late in the journey, we tend to see more of the challenges regarding data gravity. We see this especially at our customers when they're training the models or inferencing the models in the public cloud, but the data resides on on-premises systems. Then it can be quite tricky to move the data around between the cloud and on-premises. The other challenge which we tend to see quite often is around shadow AI and shadow IT. When we, as the AI solution specialists, get involved, we first try to talk to our traditional points of contact at our customers, meaning traditionally more the storage admin or the IT infrastructure specialist. And when we ask them then, hey, what are you doing with AI in your company? Where are you in your AI journey? We hear yes, or often hear, yes, we have some AI guys in our company doing fancy stuff, but we're not really in contact with them. When we're talking to the data scientists and data engineers in their companies, we tend to hear the same. It's like, of course, we have an IT department, but we're not really sure what we're doing. We are not really aware of what are we working on currently. And I think that's really unfortunate, since in many cases we see that the IT department already found solutions for challenges on which the data scientists are working on. But it also goes the other way around in many scenarios. We often see that the AI department is further with their cloud journey than the IT department. Because I think both sides would really benefit from each other if they would work better together and work better as a team from an early stage. The next 2 points on that slide, I want to treat as one: complexity and scaling AI projects. Then we see that our customers start with their AI journey. They usually hire 1 or 2 data scientists or a couple of AI working students and give them access to a workstation, on-prem workstation, or tell them to work in the public cloud. But both approaches are fine at first, but as the more the project scales and the more people are working on, and more and more project or finished models, they finish training, the bigger the challenges appear. For example, on-prem, at the point where we move from Jupyter Notebooks and Jupyter Labs to like an MLOps tool, that scaling is often not as easy as we expected. When we are working in the public cloud, we see that the costs are usually going up way faster than they initially expected. And those challenges are not bad if they appear in an early phase of a journey, but if they appear in a later stage, they can be really difficult and costly to solve. Thus, it's really important for the companies to solve those challenges in an early stage. From my European and especially German perspective, I think most of our customers, if we have a look on Gartner's AI maturity model and scale, are in an early phase. Like most of them are level 1 or level 2, with some reaching level 3. But when I talk to my American colleagues, I actually realized that many of their customers are like on average, like half a level farther than the German companies we're working together with. And we asked ourselves, how can we help them? How can we help our companies in Germany to like bridge the gap? And we're working on 2 strategies, therefore, with the first being working together with AI consultancies, but also we're working together with an AI accelerator called Applied AI. They claim to be Europe's largest AI accelerator, and they're part of a technical university of Munich. And together with them and their partners, we can help their customers and also our customers to really solve those challenges I showed in the previous slide before they get into problems. When I started out at Netapp, I came fresh out of data science and still had a very strong data science mindset in my head. And I was really surprised when I learned how many technologies Netapp had to offer, which would have greatly benefited me in my time as a data scientist. For example, data versioning is a huge challenge for many data scientists and also for me back then. But with snapshots, you could really facilitate that process. Data cloning and data copying could be really facilitated if you have access to flex clones, our writable snapshots. And I really fell in love with the data fabric story, since in my opinion, that's really a good chance to fight data gravity and to overcome data gravity by making it really easy to move data from the edge to the core to the cloud. But I asked myself, if those tools are so cool, why don't more data scientists actually use them? And I think one of the answers, therefore, is that it's not the data scientist's job to be an IT infrastructure expert. But wouldn't it be great if we could give access to those solutions to the data scientists from their working environment with like one line of code without them having to be storage experts? And with that thought, I will hand over to my colleague, Mike Oglesby.
All right, thanks, Max. Appreciate it. So it's great to be here with y'all today. So it's especially in person. It's been a while. I feel like I'm traveling back in time a little bit. So good to be here. My name's Mike Oglesby. I'm a senior technical marketing engineer focused on MLOps solutions and tooling at Netapp. And as Max mentioned, I'm going to dive into some of the tools and capabilities that we're working on exposing to the data scientists and data engineers of the world. And I like this quote right here, and I wanted to start with it because I feel like it really encapsulates what we're trying to do on our team. Andrew Ng, who I'm sure all of you know, he's one of the foremost thought leaders in the deep learning world. He says ML model code is only 5 to 10% of an ML project. And working with our customers, I'll say we definitely have found that to be the case. So if the ML model code's only 5 to 10% of a project, what's the other 90 to 95%? Andrew calls it the POC to production gap. And basically, this is everything that's not the model itself, right? This is getting the data there so you can use the data to train the model. This is managing the data. This is all the infrastructure that, you know, because as much as we all wish infrastructure would just go away and disappear, infrastructure still exists and it has to work and everything has to run on infrastructure. And so this is basically everything that enables the data scientists to do what they do best. And, you know, obviously we at Netapp are not going to solve all of the world's problems, but we've been working hard to take some of our storage capabilities and present them to data scientists in an easy to consume format so that we can help bridge some aspects of this gap and help them bring their models into production. So what are these capabilities? All of a sudden my clicker's not working. Let's use the space bar. Oh, what are these capabilities? First, I'd like to start with a tool that we've developed that takes these capabilities and presents them to the data scientists and data engineers of the world. And then I'm gonna jump into the capabilities themselves. So the Netapp Data Ops Toolkit. What is the Netapp Data Ops Toolkit before we talk about what it can do? It's just a Python module. It's a super simple Python module. When we first started talking to data scientists 4 or 5 years ago, you know, Dave and myself and the early members of our team, you know, we found that we had a lot of capabilities on the truck that were, you know, could really help solve some gaps in the data science process, but data scientists are used to working in Jupyter notebooks with Python modules and Python libraries and Python code, right? They're not used to all the IT storage admin stuff, and that stuff was just too complicated and unapproachable for them. And so we decided, let's take those capabilities and wrap them in a super simple Python module that's designed to be approachable for data scientists, developers, DevOps engineers, MLOps engineers, so that they can actually take advantage of these capabilities. You know, it's just like any other Python module. You can install it with pip. It's free and open source. If you already have Netapp storage, you go download it and install it today. We've got 2 different flavors of it. One that supports VM and bare metal environments. We call that the Netapp Data Ops Toolkit for traditional environments. And then we have another one we call the Netapp Data Ops Toolkit for Kubernetes that's designed for Kubernetes specifically and brings some cool additional capabilities that take advantage of the Kubernetes API and scheduler and the workload management capabilities that Kubernetes brings. So that's enough about that. What are these capabilities that we're trying to get into the hands of the data scientists? What are these capabilities of ours that they're using to help fill these gaps in their process? The first is around workspace creation. So, you know, what we usually find when we go talk to a data science team for the first time is that oftentimes they've kind of been working in their own silo. You know, IT didn't really know how to support them. They didn't really know how to get support from IT. And so they just they were forced to set everything up themselves. And one of the big bottlenecks in their process is typically creating the workspaces, the development environments that they work in to train their models and validate their models. And we see a lot of manual provisioning and copying data, you know, tedious manual processes that take hours, even days for some of these larger data sets. They're typically not using enterprise caliber storage. So there's, you know, often no data protection. If something happens to their machine, their stuff's just gone. There's no traceability oftentimes, which I'll touch on as a big challenge. And it's really, you know, they're having a hard time getting from idea to a workspace where they can actually implement their idea. And so in the data ops toolkit, we built the ability to just in one CLI command or one Python function call near instantaneously provision a workspace that's backed by Netapp storage. So if we're talking the VM or bare metal version of the toolkit, they can one simple function call say, hey, I need a 500 terabyte workspace, to store my data in, store my notebooks, my Jupyter notebooks in, what have you. And a couple seconds later, they'll have mounted on their machine a 500 terabyte NFS share that is at the path they specified, and they can just get to work in it. If they've got the Kubernetes, if they're running in Kubernetes, we can do something even cooler. They can say, hey, give me a 800 terabyte Jupyter Lab workspace. And just a couple of seconds later, they get a URL they can use to pull up their Jupyter Lab workspace. It's backed by Netapp storage, persistent storage, but they don't have to know or care about that. They just know that they needed an 800 terabyte Jupyter Lab workspace, and they got one a couple seconds later. They can log in their web browser, pull in all their data, save their notebooks there, and get to work.
I see there's a lot of parallels between this and infrastructure as code tooling, as like Terraform and Ansible and such. Did you like draw inspiration from there, or?
Yeah, so my background is actually in the DevOps world. So my background's on a application development team for a financial services company, and so I was I've done a lot of work on Kubernetes and with Ansible automation, and so yeah, we drew a lot of, basically we kind of drew inspiration from that world and tried to marry it with the feedback we were getting from actual data scientists and build them something that would be simple for them to use and consume. Because we've got a bunch of Ansible modules, right? It's easy to automate Netapp stuff with Ansible, but data scientists, they don't know Ansible, and they're used to Python code, not a bunch of YAML and Ansible playbooks. And it's even Ansible is kind of out of their wheelhouse. So we tried to apply the same concepts and bring them in a format that they could use in a kind of self-service way. So I've talked about provisioning workspaces, but deep learning, training deep neural networks, it's an extremely iterative process, right? So it's not just a one and done thing. Data scientists don't just get some data, run a training job, they're done, it's over, that model's done, and they deploy it to production. Usually there's a lot of experimentation and tweaking, and they'll run the same training job over and over and over again as they try to refine their models. And oftentimes this necessitates modifying something. So they'll have a workspace and they'll need to make a copy of it for a particular experiment so that they can modify a data set while preserving the gold source, tweak some hyperparameters, what have you. And this, our customers have told us, and Max has told me from his data science experience, is a huge, huge, huge common bottleneck. And there's a lot of time spent around with data scientists drinking a coffee and getting irritated while they're waiting for some copy job to complete when they really just want to get on with their project. And so, yeah.
Are the data op functions something that you invoke directly from Jupyter, or is it something you invoke outside of Jupyter notebooks, or both, or?
Yeah, so both and, yeah. So it's packaged as a Python module, right? And there's a CLI interface and a library of Python functions that could be imported into a Jupyter notebook or any Python programmer workflow. So like a data scientist working in Jupyter, if they want to clone their workspace, they just call a clone workspace function. Source equals new workspace name equals, and that they don't have to.
They tie the the Toolkit calls to a Netapp storage solution, or how does that tie-in work?
Yeah, so on the traditional Toolkit side, VM and bare metal side, it's built on top of our REST API. So it's using our Python SDK under the hood in the REST API, but it's taken these complicated API calls that we tried to say to data scientists, hey, make this API call, and they were like, what the heck is that?
Yeah.
It's taking them and wrapping them in like a simple function, basically. On the Kubernetes side, it's built on top of Astra Trident, our CSI driver. Yeah, so same idea.
And there's different versions of Jupyter now, like Jupyter Lab versus regular Jupyter. Do you guys support both, or?
Yeah, so on Kubernetes, if you want to manage workspaces at the Jupyter Lab level, we support Jupyter Lab there. But our library of Python functions, you could use that from any Python-based interface. So it could be the old notebook interface.
Right.
Yeah, it could be your laptop.
Yeah, so kind of off topic, but
Yeah.
you're talking to data scientist needs right now, but is the data ops toolkit for all kinds of data ops workloads and problems and solutions?
Yeah, so we primarily developed it for data scientists, but we have found that we've actually had customers on more traditional development teams and DevOps teams that have started using it. So we've worked with a couple of customers in the semiconductor space who are using it to build clones into some of their EDA workloads so that they can quickly have a workspace for a validation job or something like that.
Yeah, like it's just starting in just the traditional database world as well, this whole concept of data ops.
Yeah,
So.
and we actually, to that point, we first called it the Netapp Data Science Toolkit. We changed the name to Netapp Data Ops Toolkit because we were finding this interest outside of data science.
Yeah, so the other question I had, so we've just heard a presentation about very giant volumes of data, right? Like just mind-blowing that we talked about. But you're talking here about copying and moving and stuff. But traditionally, when we're dealing with not just big data or very big data, but giant data, we tend not to move it or copy it and everything just because it's so big.
Yeah.
So what's the sense of data scale with what you're talking about with this solution?
So we find that our customers typically fall into one of two broad categories when we're talking to data science teams. There's the more traditional HPC folks who have just massive amounts of data, scale out clusters, big file systems, and they tend to not move or copy things around as much. And then there's the more traditional enterprise customers who maybe they didn't do a lot of data science until 4 or 5 years ago, and they started to implement some of these deep neural networks, some more cutting edge deep learning techniques. They, unlike the big massive scale out folks, they're usually working with smaller data sets and doing a lot of copies and iteration. And the toolkit, the cloning capability is definitely more applicable to the latter group there.
Yeah, got it.
Yeah, we've found that both appreciate the snapshot capability, which I'll get to in a couple of slides here. But that gives me a good segue. So we've been talking about developing and training models up to this point, right? Well, there's this whole other piece of data science, right? Once you've trained your model, you have to actually deploy it so that it can do something and deliver actual value. And that's where inferencing comes in, where you're actually using the model, right, to make predictions and be it real time or in batch. And in the early days of deep learning, there was a pretty big gap from having a model to deploying it. You had to basically build a custom web server for every model and build your own API on the front end, or integrate it in a custom manner into your web app. But a lot of tools have emerged to make that simpler. And one of my favorites is the Triton inference server from our partners at Nvidia. You know, from when I started to dabble in this space to where we are now with something like the Triton inference server, it's amazing how far it's come. Basically, it's, if you're not familiar with it, it's a pre-built web server with a pre-built API, and you can just drop in your model. It supports all of the standard frameworks like TensorFlow, PyTorch, what have you. And you just drop in your model, and then you can call this API to perform your inferencing. You don't have to develop anything except for the model and a little config file. So you drop that in, but there are some challenges around hooking it up to your storage, because it needs storage to serve as the model repo. And if you're not in a very vanilla hyperscaler environment, there's some customization that's required there we found a lot of customers, it's kind of like the other things we've talked about outside of their wheelhouse. And so we built a very simple operation in the DataOps toolkit that enables data scientists or MLOps engineers to, with one function call or one command, deploy a Triton inference server and have it be hooked up to a Kubernetes persistent volume that serves as the model repo. And so they can just drop their models into this persistent volume, and they'll be automatically picked up by the Triton inference server, and they can start hitting the API as soon as they drop it in there.
My understanding, a lot of the models and stuff like that are using, I'll call it Git or GitHub kinds of solutions to control their sources. I mean, does the DataOps toolkit natively interface with GitHub, or how does that play out?
No, there's no native interface. So it's meant more for the development environment. So what I've seen customers doing is they'll use it to provision their development environment or their inference server. And then within that environment, they'll, pull stuff down from GitHub, pull some data in, run their training, maybe commit some code back to GitHub. And that's a good segue to my next slide. For traceability, save their snapshot ID in GitHub when they commit the code. So they've got a traceability from their data set to their model. There's sometimes a model repo involved too. So the code goes to GitHub, the data goes into a snapshot, and the model goes into a model repo. And with that snapshot ID, you can have full traceability from the actual data set that was used to train the model, to the code that defined the model, to the actual model itself sitting in that model repo. And we have a financial services customer who basically told us when we first started working with them, we got all these great ideas. We've trained all these models. Our compliance guys won't let us put them in production because we kind of didn't think about traceability. And I use these folks as an example, but we've had, I can't even count on two hands how, it would take more than two hands to count the number of customers who have told me that. And when they started using snapshots to save off a point in time copy of their workspace and implement that traceability with the snapshot ID to the code in GitHub and to the model and the model repository, they were able to check that compliance box and start actually putting models into production. All right. So I'm gonna quickly touch on these next couple slides just in the interest of time. So oftentimes there's a high performance training tier, right? And we're telling customers to save off snapshots for traceability. You don't want those snapshots to fill up the high performance training tier, right? That with that expensive, powerful storage. And so we have a lot of customers who are taking advantage of our cold data tiering. We could spend a whole presentation on these cold data tiering capabilities, so I won't go into them, but basically they'll have the snapshots tiered off to an archive object storage tier or an archive file storage tier, so that they have one front end interface, but they're not consuming all that high performance storage in their high performance environment with these point in time backup copies that are for compliance.
And that is all driven through the data ops.
The cool thing about the tiering is you just set it up once and then it just happens.
Policy.
Yeah, it's policy driven. So the data ops lets you take the snapshot and then it just automatically gets tiered off as cold data.
In terms of practical customer applications of this, how much data are we talking about for typical customers that can be tiered out to cold data instead of kept online?
So that's a great question.
Situation.
Yeah, I know. I mean, I know customers who are in hundreds of terabytes of scale with their data sets they're managing, and Dave, you might be better positioned to answer that than me, but I know we're talking big numbers here.
Yeah, I was going to jump in and say I've got a couple of customers. I'm working with a large pharmaceutical customer now who is talking about petabytes of raw data. They need to store petabytes of raw data. They only usually use a couple hundred terabytes of that at a time for any given training job, right? So the fabric pool tiering means that data gets ingested, it gets written into a high performance store, and then based on an age policy or whatever, it gets moved off. If somebody calls that back up, it gets brought back up into the accelerated tier.
They're snapshotting hundreds of terabytes of data.
They're snapshotting a volume that may have 100 terabyte or hundreds of terabytes of data in it. Now remember, a Netapp snapshot is completely space efficient except for any changes, right? So if I take a snapshot of a 500 terabyte volume and then write 500 gigs into that volume, I'm only consuming 500 gigs of extra capacity. The other option here is the flex cache is kind of the reverse. And I noticed a thing on your slide. I would say for flex cache, it's automated hot data tiering, right? So the idea with a flex cache is that, well, I've got another customer where we've provisioned a very large cluster of hard disks and then a much smaller cluster of flash systems that's directly connected to the training systems. And all of the data goes into just a standard hard disk repository. And on a case-by-case basis, either on demand when a user just kind of references a piece of data, or in advance, we can pre-populate that cache so that as a data scientist is getting ready to execute a training run against something specific, they can elevate what would be kind of colder data up into a performance tier.
In terms of data ops, that's one of the things that I've heard is that a lot of people are starting to think about trying to save a copy of a data set that's consistent with a certain model at a certain point so that they can then go back to that if needed. And is this what people are doing with the Netapp snapshots then?
Yeah, that's the entire point of the traceability comment that Mike's making, right? Is that once, and this goes to some of the original questions. I didn't want to jump in then, but, the concept of DevOps has been around for a long time, and the concept of continuous integration and continuous deployment, right? And a lot of the data ops toolkit is built on those same premises with the idea that these workflows have the same processes, right? They're software developers, they're developing software. When they reach what they think is a done point, they run some automated testing on that. If that testing passes, then that model gets moved, or the software gets moved into the next phase of the process where it may get deployed or what have you. The data ops toolkit really enables all of that same kind of automation that people were already doing for more traditional software development. It just adds the element of the data also, so that instead of just taking a snapshot of your actual code repository, we can simultaneously take a snapshot of the code repository and the data that was used to train that code. And that makes a big difference in that traceability question.
Yeah, and this topic, or this concept of snapshots for data set to model traceability, it's been extremely popular and generated a lot of interest with our financial services and healthcare customers, especially because because of
compliance, because of traceability and all that stuff.
Regulatory compliance. We've had so many conversations with customers where they told us they were kind of stuck in the science project phase and they were really struggling with that traceability, and we've been able to help some of them get over the hump.
And so in that situation, the model, the code, the data, and all that stuff would be on a single NetApp volume or something like that, and they would snapshot that, and they would have it. They could tag it, and then keep it around for as long as they want.
For as long as they want, archive it off to an S3 object store. You know, do whatever else you would want to do to protect that from a compliance perspective.
And if there's ever a question around, hey, why'd this? You know, how'd you train this model? It's
Bingo.
made a weird prediction. You can go pull up the exact environment.
Not unlike a container to some extent with the infrastructure associated with it. Yeah.
Yeah, exactly. Yeah. So those, in those two industries especially, we've found that customers have, it's really helped them bridge that gap. So I'm going to go ahead and jump into a demo. Just to keep us on schedule, I want to make sure we don't miss the demo here. So this is just a quick demo showing how with the DataOps Toolkit, you can near instantaneously clone a Jupyter Lab workspace. So let's start this guy here. So basically, let's say I'm a data scientist here. I'm working in that Jupyter Lab workspace, and I need to clone it to drive an experiment. So I can go into my terminal. I could have done this with a Python function call as well. So I've run this list Jupyter Labs command here, and the workspace I was in is that project 3-Mike. So I want to clone that one, so I can modify something, maybe change the data normalization technique, what have you, to run an experiment, but preserve the gold source. All I do is run this clone Jupyter Lab command. I could also call the clone Jupyter Lab function from a Python program. I specify the source workspace name, the new workspace name, and that's all I have to do. And I press enter, and it calls out to the Kubernetes API, and it's going to clone the volume behind the scenes. I don't have to know or care about any of that. I just know that
it's important to know that cloning is a read-writable structure. It's not Snapshot, which is only readable, right?
Exactly. So the cloning is more for that experimentation. You need a read-write copy. So it calls out, it clones that volume, and it spins up a new Jupyter Lab workspace on top of it. The cool thing is as a data scientist, I don't even really have to know that a NetApp volume was involved. I just know that I had this 2 terabyte workspace, and I get an exact copy of it. So I can take this URL here and go over to my browser, and I'll have an exact copy of that workspace I was working in. So I got some images and a notebook in it. If we pull up the copy, we enter the password we just set when we ran that command, and we got the same images data set and the same notebook. So it gave us an instant copy. It's going to take the same amount of time, whether it's 2 terabytes like this one or 500 terabytes, because it uses the NetApp, the old school tried and true NetApp cloning technology under the hood. But it presents it in a way a data scientist doesn't have to say, okay, which volume is it? How do I find that in the storage interface? Can I even get access to the storage interface? Do I have to submit a request? Oftentimes they don't even know cloning exists to submit the request. So it just makes it super simple, and they can manage things at the Jupyter Lab workspace level.
So I have one question about that. Like, not seeing the abstraction is good mostly because I'm living in Python. I don't need to care about infrastructure.
Right.
But what can I screw up with this?
So that's a good question, because there's some important prerequisites to giving a data scientist access to this. Yeah, so basically, typically what our customers will do is they'll set up a sandboxed environment. So if you're familiar with NetApp, that would be an SVM, a storage virtual machine. If you're not super familiar with NetApp, the important idea is just it's a sandbox within the storage system that you can set some limits around and give specific access to. And so basically, this is what most of our customers are doing. They give the data scientists a specific environment with some limits that they can use for their development. And so they can do whatever they want in there. but they're not, they're totally sandboxed from the rest of the environment, and they can't stomp on anybody else's stuff. We do have customers who give the data scientists a whole dedicated cluster, but those are more the more advanced customers who are kind of further along in their journey and need the horsepower of a whole dedicated cluster. So with that, I'm going to hand it back to Max, who, we talked about CLI versus function call. He's going to show what it looks like when a data scientist is actually working in a notebook.
Sounds good. And it's going to get exciting since I'm going to try to run a live demo.
So while he's doing that, so any support for other types of notebooks, or, because everyone's building the next best notebook. So
yeah, so at that workspace management abstraction scale on Kubernetes, we only support Jupyter, but we also, there's basically two options. You can manage it at that level or at the NFS share level. Yeah. And so we've got customers who are using things like RStudio, and they'll just say, hey, they'll call create volume instead of create workspace and say, I want it mounted at this create volume size, 500 terabytes, local mount point, / home, whatever, and they'll manage it that way. Okay. Yeah.
Thanks.
No problem.
So I think it actually works with a live demo. For the live demo, I want you all to imagine that I'm back in data science, and we've been just handed over a data set from our boss, let's call him Mike, and it's our job now to basically first clean the data, analyze the data a bit, and then build a simple model. As a data set, we're going to use today NASA's turbofan degradation data set. Basically, in the data set, you have many different turbofan engines, like you have them on the airplane, and you try to predict how many more life is in those engines before they need a major service. In the beginning, we're going to just import all the libraries. Shout out to the Netapp DataOps Toolkit traditional library, but also to QDF and QPy from Nvidia with the Rapids AI, just to speed up the data wrangling massively. Next, what we're going to do is using the Netapp DataOps Toolkit to give it an overview about which volumes do we currently have access to. And here we see analytics data. That sounds good. Let's have a look into that one. Engine data, I think that's the one. But as a data scientist, you should never, ever work with a golden sample. And that's also what Mike just said before. In my time as a data scientist, what I did was just copy all the data around with which I wanted to work so that I didn't manipulate the golden sample by accident. But with a flex clone or with a clone, it's way easier and way faster. So just one line of code to specify how it should be called, where it should be mounted if you want to. Wait a couple of seconds, I think 12 seconds in particular right now. And I ran the demo a couple of times before setting it up, yes. And yeah, you're done. You can work with it as if it would be a complete copy of it. You can do everything with it. And yeah, my next steps, I'm going to get kind of quickly over it. I'm just going to read in the data, do some data analytics, data wrangling, nothing interesting for this demo here. Some data analytics, exactly, cleaning the data. Where it gets interesting again is right here. When I finished cleaning the data, the next thing I should do is save the data to a separate place. And therefore, I want to create now a volume using the Netapp DataOps Toolkit. Thus, I just write one line of code, create volume, specify how should it be called, how large should it be, where should it be mounted, and done, basically. I can save in the data. But what I'm going to do next is create a snapshot of a volume, and you're going to see, I think you can see already now where I'm going with that. As a data scientist, or in my time as a data scientist, it happened to me, yes, I have to admit it, that I actually deleted the data set, which I just cleaned. And as a data scientist, you really have a bad time if you have probably not any more access to the cleaning script. But if you just created a snapshot of it, it's not a bad time at all. All you can do is restore the snapshot, one line of code, and your valuable data is, give it a couple of seconds, is back. No bad day, you can rest assured that your evening beer is saved. Next, I'm just going to create a simple model using XGBoost for the data. Wait a couple of seconds. And as soon as the model is trained, we have now a choice. Either we could use the new functionality of a Netapp DataOps toolkit to directly deploy the model to Nvidia Tried Inferencing Server. But for the simplicity of this demo, what we're going to do next is just create a new volume and save a model into the volume so that we can give access to our colleague who's then putting it into production for us. So are there any questions regarding the demo, or can we go back to the slides?
Where's the results?
Yeah, what are the results?
So we have an
just delete them all down.
So we have an RMSE of 9.5.
No, I bet like in a typical demo, you'd swap over to a dashboard that showed you now had or whatever you did.
Unfortunately, no sexy dashboards for this demo. Just the Jupyter notebooks and Jupyter Lab.
Yeah, so cool. Easy demo. You didn't have to type.
True. Yeah. But honestly, I was just super glad that it ran through the demo.
Yeah.
No, one question I have about this though, and forgive me if I've missed something, but it feels like there is a Python API to the storage, like so it's exposed to that. So as a data scientist, I still actually need to know a bit about these infrastructure primitives, like what's the difference between a clone and a snapshot. Can I work on a higher level of abstraction for this where like the infrastructure team deals with that and like handles policy and stuff, and I just go, I want to do this thing and you figure out how that actually happens underneath?
Yeah, so one of the things we're working on is trying to bring this up a level further, right, and get it into like an MLOps platform. And we have a couple of customers we've worked with who've built their own kind of custom in-house MLOps platform, and they've integrated these capabilities into that. So basically, you know, the data scientist is in some dashboard and they're right. All right, they click clone. They click, I want a copy of this workspace, and then it just behind the scenes it does the clone and presents it to them. So I think your question hits on what our ultimate goal is. We're still kind of on the path of getting there.
Cool. So let's get back to the slides. And let's give it a couple of seconds. We see the recorded demo. So after having now talked about how the Netapp DataOps Toolkit can really help the data scientists and data engineers in their daily lives, I want to talk about an architecture, how we tend to see it at our customers, and how we like to promote it at our customers. When we, the AI solution specialists, get involved, usually currently the data resides on some sort of Ontap, on-prem Ontap system. But in many scenarios, our customers want to resume or start the AI journey in the public cloud. And thus, they first get into contact with the hyperscaler of choice. And the hyperscaler of choice then recommends them to use their own natively integrated AI working environment. That could be a Google Vertex AI, that could be AWS SageMaker. But no matter what choice, we tend to see two downsides of those integrated working environments for the customer. First, it makes it for the customer quite difficult in the future to switch to another working environment, to another AI working environment. Second, the hyperscaler tends to recommend our customers to upload the data to an S3 bucket. And that's totally fine if the data is not oversensitive. But we see from our customers that some customers do not feel comfortable or many customers doesn't feel comfortable uploading their highly sensitive data to an S3 bucket. What we like to propose them instead is to use some cloud-based Ontap available at all three hyperscalers. And with those cloud-based Ontaps, you can securely encrypt your data at any point in time. And also, you could securely transfer the data between the on-prem Ontap and the cloud-based Ontap so that you do not risk losing the data or giving by accident access to other people to the data. What I personally really like to promote is to put in between the on-prem ONTAP and the cloud-based ONTAP Netapp Cloud Data Sense. It allows you to scan through the data regarding data privacy issues and to scan it whether there's parts of the data in there which probably you do not want to have in the cloud and which might be information regarding religious beliefs or something like that. And yes, you probably even on-prem you shouldn't have the data, but as the data just ages, we see that our customers sometimes by accident have those data, and I think it's a good point of safety for them if they can scan the data before just transferring the data to the public cloud. As soon as the data is then in the public cloud, our customers really have a choice of MLOps tool. They could either choose an open source product like Kubeflow, but also they could go with one of our partners, MLOps tool like a Domino Data Labs or Run AI or Equasio. No matter which of those products they're choosing or approach they are choosing, it's really easy for them to move to another hyperscaler, also move back on-prem, because thanks to the cloud-based ONTAP, it's really easy to move the data to the place where they need it, when they need it. And that's actually also what we heard from the AI Accelerator in Germany, that they really enjoy working together with us since we make it that easy to move the data around to the place where they need it for their customers. And actually, Mike has a customer experience where they use an architecture close to this one in practice.
Yeah, and I'm going to just quickly touch on it because I want to try to keep us on schedule here. But basically, it's a really kind of unsexy customer reference, but it get not in terms of the customer, but just in terms of the architecture. But I think it's a good example of some of the simple problems that something like a cloud ONTAP could solve for a data scientist. We were talking to a data science team at one of our customers, and basically they were in EC2 instances in Amazon AWS running training straight from S3, and they were having trouble sharing data, and they were having trouble getting the performance they needed. It was taking them forever to run their jobs. They were paying a lot of money for these expensive GPU-based EC2 instances, and so just a simple solution. They started using Amazon FSx for Netapp ONTAP as kind of a shared training environment, so they could all mount that on their EC2 instances, bring down data sets from S3 there, do whatever they needed to do to them, and then max out their GPUs. They needed shared access to it, which they couldn't get with using EBS. And so simple use case, it kind of really solved some big problems for them.
Cool. So when we're already talking about cloud AI, I want to have a look on a bit different part of a Netapp product portfolio, and that's Spot by Netapp. I think you've all heard by now that Spot by Netapp can offer or offers a lot of different cool solutions to facilitate in your cloud journey and also to make your cloud journey more efficient and cheaper. But I want to have a look in particular into two different Spot tools, which we like to pitch and see at our customers and which can make their cloud AI journey better and more efficient. First, I want to start with Spot Ocean. Spot Ocean is our serverless infrastructure engine for containers. Basically, it continuously optimizes your container infrastructure in the public cloud by right-sizing your pods and containers, by recommending you and helping you to find the right instance types, but most importantly, by helping you to consume the cheapest consumption option of compute instances. And that's, as we all know, those are Spot instances. But most companies do not want to use Spot instances for their customer-facing applications, since they can be Spot instances can be terminated at any point in time. But that's exactly where Spot Ocean comes in, since Spot Ocean automatically reschedules your containers to another instance consumption type, so that your customers never feel it when one of your Spot instances got terminated. Overall, combining those services, Spot Ocean can save up to 80% of cloud compute costs. And how we see it with our AI customers is that our AI customers in the public cloud really enjoy Spot Ocean for running their inference. For example, they can use Nvidia Stratton's inferencing servers and let it be managed by Spot Ocean, and will save a tremendous amount of money simply by letting Spot Ocean manage that deployment. The other tool, which I quickly want to go over, is Spot Ocean for Apache Spark. That's basically a fully managed fully managed Apache Spark in the public cloud. It's based on Spark on Kubernetes, and is obviously fully Spark-aware infrastructure scaling. It allows you to deploy that Apache Spark in the public cloud really easy. And best of it, in my opinion, is it uses the same engine as Spot Ocean, and thus make it very cheap for you and allows you up to 60% cost savings running Apache Spark in the public cloud. Currently, Spot Ocean for Apache Spark is available for AWS, but with support for GCP coming soon. Actually, that's it from my part. And if there aren't any questions, I would hand over to Dave. Thanks.
Log myself back in. All right, thanks, fellas. I love those demos. That really brings home just kind of how much easier that can save time, right? Copying data sets, nobody wants to wait for data sets to copy. It doesn't matter if it's a 500 terabyte data set, that clone is basically instantaneous and ready for use right away. So that makes a really big difference here. So I'm going to move on. Unfortunately, we're kind of talking about a lot of things around here, but a big portion of the focus here is the actual infrastructure that goes on. We basically, so I'm kind of focused more on the physical hardware and the connectivity and the presentation of these kind of resources, so that the data science can then do their magic, right? So there's a couple of things I'm going to talk about here, but before I go into it in kind of some of the technical details, I want to talk about why it's important here, right? I mentioned that we've been working in the space for several years now. And there's some things we've learned from our customers here, right? The first thing is that AI model development, actually training and validating of models, takes some pretty specialized infrastructure. It can be done on CPUs. It can be done anywhere at any time. But the big challenge is the amount of time it takes to get it done, right? So there's a lot of customers who are starting their AI journeys on CPUs. And then realizing that it just simply takes too long. I think one of the early quotes that I loved from the Nvidia guys was that the accelerators allow a data scientist to see his life's work done in his lifetime, right? Instead of these techniques have been around for 50 years in some cases. The guys who invented these techniques never saw it actually work because the compute was just literally not fast enough, right? So with the specialized infrastructure, that's getting really challenging for customers these days, when most customers are downsizing their data center footprints. They're outsourcing IT initiatives and support and stuff. So the notion that we have to bring in some new kind of big iron horsepower is really challenging for a lot of customers. That in itself, as Max mentioned, is actually driving shadow IT, right? The data scientists are fed up with waiting for the IT guys to give them something they can use. They swipe their credit card and go get some compute in the cloud, or they go buy a system from whatever vendor walked through the door and said, that, hey, we got this great thing, and it may be great for that guy on that day, but as the business matures and as the needs grow, those things almost never work out, right? There's a reason why people don't like shadow IT, and down to some of the compliance things, right? Data scientists may or may not really care of the legal ramifications of some of the things they do, while their IT departments and their corporate compliance officers are extremely interested in the things they're doing.
Where do you come up with that first number? Because in any business of any sort, there's all sorts of small projects or pilot projects that aren't ever really intended to go into production. They're intended as a once-off type thing. So I mean, coming up with this 53% number, it's
well, that number came from a Gartner survey down there in the bottom.
Yeah.
I didn't pull that number out of thin air.
okay. Gartner pulled it out of thin air.
Gartner may have pulled it out of thin air. I won't dispute that fact, but I got it from somebody who claims to know what they're talking about.
Okay, it's like it's a meaningless number as far as I can tell.
It is, and that number varies from customer to customer, right? We've definitely seen customers who are essentially clueless at what they're doing here, and they're fumbling around in the dark, and they got a data scientist, and he showed somebody something really cool, and they said, okay, let's do more of that, but they don't really know what they're doing, and they don't really know how to get it there. Then we've got customers who are way beyond that number, and they're already actively getting mature projects into production,
Okay.
right?
Or they've embraced fail fast.
Or they've embraced fail fast, right?
One of those two things.
I'll say actually getting that kind of infrastructure and those kind of capabilities in-house and usable by the users who need them is a part of that problem. I'll say, for that, to that point, right? Like, it's really easy to build data sets that are a lot of the challenge we see with getting things into production in AI, to your point, is it's not about, like, can I get a server and put an application on it and run it? The challenge is the data, right? And the data is coming from everywhere. And I'm going to kind of go into a little bit more of this in the beginning, but it's easy enough for a data scientist or a data engineer to pull together a data set that he can experiment with, that he can show something interesting that appears to solve his problem. That's not that big of a challenge. What's challenging is reproducing that every single week, so that every week you get new updated data, the models get updated consistently, and so on. And that's where things start to break down, because that one guy who spent days and days and days building and massaging that data set can't spend the rest of his life doing that same thing, right? That was just to get it off the ground. So that's been one of the big challenges.
So I'm interested in your last number, actually 80-90%. There's a lot of, at least IT departments that and data centers where they say they have, virtualization first approach. They're going to virtualize everything, which I'm not sure I agree with as an approach. But how much of a problem do you think that is when you're talking about AI systems?
Well, so that is actually one of the things. Nvidia's got a solution, right? The challenge to address here is that at the end of the day, this specialized infrastructure is expensive, it's complex. Like I said, IT departments are losing skill sets. They have VMware estates. They know how to run VMware estates. They know how to use that platform, right? So the goal here is to actually get that into use for the AI development, right? I mentioned that, you can do AI on CPUs, and there's a lot of customers who are doing it on VMs because that's what's easy enough to deploy, right?
Yeah.
The next step of that evolution is to give those people GPUs in their VMs. And so one of the things I'm going to talk about in a minute here is the NVIDIA AI Ready Enterprise program, which basically layers a whole bunch of this cool NVIDIA software on top of the VMware infrastructure, right? Using servers that have GPUs and so on, really allows you to kind of achieve all of the kind of functional benefits without maybe the big iron horsepower benefit, right? So maybe you don't have a 20 node cluster of DGX A100s or something, but you've got 50 or 100 servers with one GPU each in them, and every data scientist gets his own machine, and those kind of benefits. So there's a lot of benefit to be had from enabling AI development in a VMware environment. And I can touch on that in a bit more here. Well, and that pretty much covers what I wanted to catch here. So to that point, right, the challenge here, like I mentioned, is not necessarily around just having a machine that does it, because the machine itself is only part of the process, right? There's a whole range of things that need to happen. There's a whole range of access requirements, right? Like what protocols users use for certain steps, what other things are there. So there's kind of three key infrastructure solutions I want to touch on here. One of them is our Ontap Ai. That's been kind of our flagship from the beginning. That's actually available in kind of three flavors now, basically as a do-it-yourself reference architecture. It's also available as a turnkey, I want to call it a single SKU solution, right? So you can order from a partner vendor, basically the servers, the storage, the networking, and some of the software bits to build a complete solution. We've also got the DGX Foundry from Nvidia with Netapp that Adam's going to talk about here in a lot more detail. But that's basically this architecture as a subscription-based service, so you don't have to buy anything at all. You can just rent it and immediately go to work on it. Excuse me. You may have heard last week our big announcement for SuperPod, the Netapp E-Series storage system was certified on the SuperPod platform. Nvidia DGX SuperPod is the Nvidia, basically world-class blueprint for a world-class supercomputer. And then the last thing I mentioned there was the Nvidia AI Enterprise. So I'll touch on a couple of details there. But this is the picture I was going for next here, right? This is kind of a better look at, across a whole range of development options here. There's a lot going on in this space, right? It's not just as simple as collect some data, run a training job, whatever, right? That data has to come from somewhere. We usually kind of call that the edge. That may be a drone flying around or an autonomous car collecting data. The edge may be the data center where you're collecting data telemetry from a website, right? Click-through rates and things like that from a website. So anywhere that data is coming from, it's going to have to get somewhere else, most likely. Sometimes those things are happening in the same data center. Sometimes they're not. The drone is not doing the heavy lifting right there on the drone, right? But what's interesting is the drone may be doing inferencing, right? The whole point of these AI models is to put them in the environment to interact with the way they've been trained to do, right? So the inferencing usually happens out there at the edge. That's where users are interacting with an application, or the autonomous car is interacting with the environment, or what have you. And not only are you collecting the data that's coming in, that's just the data, but now you're also collecting data about what your model is doing. How accurate is your model performing in the real world? How many anomalies are you seeing there? So it's kind of a compounding problem, but at the end of the day, it's referring to both kind of an ingest process and an analysis process that may or may not be happening in the same location as any of the other parts of this process. The data factory is where kind of the sausage making happens, right? That's where that raw data gets labeled and turned into actual data sets. Again, like I said, there's lots of different access requirements. Some of these are web-based applications where you don't even need anything but a web browser. Others are more direct NFS or kind of S3 type things, depending on whether they are using pre-built services or things that customers have cooked up themselves. But because that data factory is now kind of an aggregation point for all of that data, there's a lot of other things going on there, right? There's other kinds of analysis coming on. There may be other data streams coming in from a Kafka stream or existing databases, business CRM databases or things. And of course, Hadoop has been a huge part of a lot of analytics shops for a long time now, but a lot of those customers have kind of run into the limits of what Hadoop is capable of. And are looking more to things like Spark on Kubernetes. So Max was talking about Spot Ocean for Spark on Kubernetes, right? It almost makes more sense to spin up those analytics engines, as many as you need on demand, than to maintain a fleet of 5,000 servers in a Hadoop cluster and try and maintain that, right? So there's a lot of things going on there in that data factory. That may or may not be one data center. There may be multiple locations around the country or around the world where those kind of tasks are going on. And then the last step there is the training and validation of models. And we've been talking a little bit, about like HPC and stuff. This is where those things start to merge together, right? There are customers who are making these big investments in this kind of hardware to do not only AI development, but also more traditional HPC simulation type workloads. And all of that can still feed back into this whole kind of I had a colleague who called it the virtuous cycle of data, right? You get some data and you build a model and you get a result out of that data. And that teaches you more about how to do what you're trying to do, which lets you collect more data, which helps you build a better model, which helps you collect more data, which helps you build a better model, and so on. So the circle goes on.
How many times do you say data while
I know.
slide?
I was just starting to count.
Okay.
I bet it was more than 100.
It might be.
There was actually a question on the previous slide that came up.
Sure.
You were talking about the
this one,
your SuperPod with the E-Series.
Correct.
There's a question about whether your DataOps SDKs actually work with E-Series and SolidFire product lines, or are they ONTAP only?
So the DataOps toolkit does work with the BGFS. So I'll go into this E-Series thing in a bit more, but at the end of the day, it's not really the storage system at that point, it's the file system, right? So the E-Series, like we have a Kubernetes CSI driver for the SuperPod solution. And we can do some of the things with the DataOps toolkit that the platform supports, but like the E-Series, like BGFS doesn't support snapshots the way Ontap does and doesn't support cloning the way Ontap does. So some of those features we can't directly implement. But in general, yes, you can apply a lot of the same concepts there.
Okay, and what about the SolidFire product line?
The SolidFire product line, I don't believe is supported at all, right, Mike? Correct. Okay. Okay.
Thanks.
I don't think we're actually selling the SolidFire directly anymore either, though.
Isn't it based on your HCI solution? Isn't that?
HCI is discontinued, but I'm quite certain that SolidFire is still selling to several very large customers.
Couple specific customers. That wouldn't surprise me. I believe it is not generally available anymore, though.
Okay.
At right about the same time the HCI was discontinued, I think is when we stopped doing the SolidFire generally available as well. Okay, so the first one, the Ontap Ai. This was the thing I started with. This is kind of the.
So sorry to interrupt. I'm curious with the Netapp fabric from before. Are you going to talk about like all the products that make up the fabric? Because there's a lot of elements there from the same kind of semantic field, as in inferencing with Cosm Kafka, but what exactly is the data fabric?
So the data fabric is a concept that Netapp came up with a couple of years ago, basically referring to the interconnectivity of all of these different storage products we have, right? So the Ontap product that I was getting ready to start on has a few replication features built into it natively, and a lot of the things we've been talking about would rely on SnapMirror to move data between heterogeneous or homogeneous Ontap systems. For customers that have heterogeneous systems, or even like the E-Series, right? If we want to move data between that E-Series BGFS and an Ontap, we have a couple of other software components, like CloudSync is one of the products we have that can basically move data from any source location to any other source location, and can be automated. We have another product called XCP, which is currently mainly used for NFS migrations and Hadoop migrations, but we have a roadmap of support for a broader range of protocols. The big one is going to be S3 coming with XCP here shortly, in order to be able to tie together any of those environments. So we have a couple of other tools for actually moving data between the storage components. Does that make sense?
Yeah, it does make sense. So is the data fabric more of a umbrella marketing term?
It is, yeah, because there's basically a suite of products that effectively kind of make up the notion, and the idea is that based on having different, every customer is going to have different requirements and pipelines, right? The data is going to be coming from different locations, so there may be different requirements on what data movement is required and so on. And the data fabric just kind of provides a framework for us to help move the data around between any places as needed.
Right, thank you.
Sure. Let's see, how am I doing on time? I'm gonna speed up here. Ontap Ai is just the reference architecture, right? This is basically all of the major storage vendors have an architecture that looks pretty much identical to this. I'll say from from the actual workload testing that's been done, they all perform exactly the same too, because for the actual machine learning workloads, the storage is generally not the bottleneck. There may be small phases of the process where more bandwidth is required or not, but they have a very minimal impact on the overall performance of a training job. But the idea here is really to provide the customers with a pre-validated solution. We've already built it in the lab. We've done all the engineering work to identify any issues. We've tested it with both synthetic workloads and with like MLPerf benchmark workloads. And then provided prescriptive guidance for customers on sizing and deployment. We do have a document with literally step-by-step command line instructions on how to deploy and configure this whole solution, but nobody wants to do that anymore. So we've also got Ansible automation to deploy the whole thing in about 20 minutes. I've run this whole setup in about 20 minutes. I use this automation in my lab because I tear these things down and rebuild them on a regular basis. And I can basically have this whole stack up and running in about 30 minutes when I reload operating systems and everything.
Is this the SuperPod, or is this your own version with DGXs?
So this is not a SuperPod. This is what Nvidia calls a scale-out cluster, as opposed to a SuperPod cluster. This is, I'm going to touch a little bit on why you might want to choose one over the other in a minute. But no, this is not the SuperPod. I'll show you the SuperPod here in a second. Okay. The next kind of iteration, oops, I'm looking at the wrong laptop here. The next iteration of that Ontap Ai is, like I said, a single SKU model, right? So customers can work with their partners. They don't even need to be a DGX reseller, I believe. As long as they're a Netapp reseller, any partner who sells Netapp can sell this Ontap Ai integrated solution. And that's because, again, all the engineering work has been done. This is being done by the distributor Arrow. They're literally assembling it in their integration facility, installing all the software, testing everything out. Then they take it apart and ship it to the customer, stand it up on the customer site, run the validation test again to make sure it's performing as expected, and then hand it over to the customer. There's really two really nice features about this. One is that it is pre-built, right? Like you just say, I want 3 DGXs and X capacity of storage, and we can put a config out there that basically comes as a single line item. The other really nice thing about that is a single point of contact support for the entire stack. It's basically one phone call to Nvidia. We've made arrangements on the back end for Netapp to support this with Nvidia on the back end, but customers don't have to decide who to call. They call Nvidia, and if Nvidia determines it's a Netapp problem, they get us on the phone and we resolve it together. And that's a really nice feature. That's been one of the big challenges a lot of customers have, is dealing with kind of the support implications. I'm really briefly going to touch on this because I'm going to let Adam have all the fun with DGX Foundry. But as I said, this is a subscription-based service for the same thing, right? So rather than having to even think about making a purchase and spending capital expense, customers can rent this architecture for a monthly subscription basis and take advantage of not only the physical infrastructure, but also a lot of the really cool software development that NVIDIA has done for their internal development teams. I really quick have a customer case study on Foundry. This is one of the customers that did a proof of concept with us. They used a 20-node DGX cluster. Now, this was only tied to a single A800 storage system, so we got a really good ratio there, and they did not see any performance issues with the workloads that they were running on. Back to my point about these workloads are generally not storage constrained. So depending on the actual workload and the requirements, there's no hard, fast number that you have to have X throughput of storage for any given server combination. These guys ran over 700 training jobs. I think they had the system for 2 weeks. Do you know how long? Was it 3? Less?
About 2 weeks.
About 2 weeks. So in about 2 weeks, they ran 700 independent jobs and logged 15,000 hours worth of GPU time, which is really good, right? The whole point of all this is to maximize the utilization of those resources. And the customer basically, they were onboarded. They get kind of a quick overview of how to use the system, and within minutes, they're actually up and running and starting to train models and stuff. So this is just a really good example. This is now going GA, so this is becoming generally available for all customers, but this was one of our initial proof of concepts here. So SuperPod. SuperPod is kind of a totally different animal. The SuperPod architecture is basically NVIDIA, like I said, it's NVIDIA's blueprint for world-class supercomputer, right? If they were gonna design the very best systems, and of course they have, and they've built them internally, SuperPod is the architecture that they use to do that with. And then they have kind of codified that and standardized it and made it available to customers. So there's only a couple of storage vendors that are qualified to do this. Netapp is now one of 3. I think there's a 4th on the way. But the idea is really to have built and tested this solution that is capable of scaling up to the largest. So a full-scale SuperPod would be 140 DGX A100 nodes right now. And the storage system that goes with this has to be built in a way that it can scale along with the compute up to that node. So we've developed a building block system, and I'll show you that in a second, that allows the storage to scale up with whatever the compute configuration is. SuperPod is deployed as a single item by NVIDIA as well, so it comes with the services to deploy it and then validate it to make sure it's actually delivering the performance it's needed. And then, of course, the whole thing is backed by both Netapp and NVIDIA again. The storage system here, as I mentioned, is the EF600. This is a very high performance but kind of lower feature set storage system that was really intended for HPC type workloads. That's where we've been selling this thing for many years. The SuperPod configuration then is basically we've created these building blocks, and a building block is essentially, this picture is not actually accurate. It should be 3 EF600s combined with a pair of x86 servers. Each of those building blocks is then good for about 60 or 70 gigabytes of read throughput per second. And then multiple building blocks can be scaled up to whatever size is needed for the compute complex that is, that's being used.
You mentioned 140 A100s. Is it possible that it's 160?
Well, the current SuperPod definition is 140, right? But I know there have been some plans on maybe changing the scalable unit size. Is that?
But it's 20 times 8.
There's 7 SUs is the max right now for a SuperPod.
So the SuperPod's based on a scalable unit, yeah, which is 20 DGX systems. So all of the SuperPods are basically in increments of 20. You can start out with 20 systems and then scale that up to 7 scalable units. Like I said, this is a different architecture than the Ontap Ai. The Ontap Ai was in numbers of 8. Because with our testing, that's where a single HA pair kind of maxed out, was with 8 servers on the machine learning workload. For the SuperPod, it's a true parallel file system that can be scaled out across as many nodes or storage devices as necessary. So it is intended to really grow to a much larger scale. Did I answer your question?
Yes, you did. I'm not sure I understand, but I can figure it out.
Okay, you might get a little bit more when Adam does his piece too. He's got a couple of deeper topology drawings for that. So the building blocks here, like I said, we've got these building blocks. Each building block is itself a high availability unit. So the 2 servers are basically redundant for each other. The 2 servers are running the BGFS storage services. Let me back up a little bit and say, I don't know if anybody is familiar with BGFS, but there's a company in Germany called ThinkPark that is the owner and maintainer of BGFS. Netapp has developed a really strong relationship with ThinkPark to the point where we now sell BGFS off of our price book, and we support it off of our support services. So we have level 1 and level 2 support for BGFS. And then of course we have direct escalation to ThinkPark engineering if we find issues that we can't resolve ourselves. So that BGFS software is running on the x86 servers. They are running as a high availability pair for each other. They can both access all of the storage behind them. And then the BGFS allows for distribution of those services. So if even more availability or even more performance is required, you could actually mirror the same data across multiple building blocks if you really wanted to scale up that performance or reliability.
This would not be integrated with the earlier in terms of the AI.
So not to the level that Mike showed, right? So, well, for one thing, SuperPod comes with its own management stack. And so that definitely, that integration has not been done there as well. That being said, it's possible pending the, you know, provided the feature set is there, right? We're still, there's some feature gaps between the BGFS kind of because of the nature of the animal there. I'll say real quick, this we've got Ansible automation for this as well, right? So the storage components here go in very, very quickly. They've been automated and validated. So from an orchestration perspective, to your point, right? A lot of customers are running Slurm on this architecture as more of a traditional HPC batch job scheduler. But a lot of customers are also looking at running Kubernetes for more modern workloads. So like I said, there is a CSI driver and there is some compatibility with the DataOps toolkit. It's just not a complete integration because the platform doesn't support all those features. Okay, so the other thing I'll point out is that we did just go through all this certification for SuperPod, and that was an extremely rigorous testing process. But this configuration can be used anywhere. We have lots of customers who don't want a full-scale SuperPod, but they still like the idea of a parallel file system and things like that. And of course, we have a number of customers who are buying basically this exact configuration for non-SuperPod type configurations. Okay, so which one's right for you, right? I've talked about two pretty high performance platforms, and that raises some questions about which one is right. I'll say for 99% of the customers out there, it's personal preference. They both perform well enough that for 95+% of the workloads you might run on it, you would never notice a difference in any kind of performance. A lot of the enterprise customers we're talking to are not friends of InfiniBand architectures. They don't really understand InfiniBand. That's not a part of enterprise data centers really. So they really like the notion of a solution that runs on the protocols that they're already familiar with and using, like NFS. On the other hand, we've got customers, and especially in the AI space, who came from HPC backgrounds, and they'll accept nothing less. So we have the SuperPod and the InfiniBand solution to kind of satisfy that personal preference. I will say there are some workloads, things like the true HPC simulation, like the oil and gas and genomic simulations we see a lot of people are doing. That definitely lends itself more to the SuperPod type configuration. And there are a couple of AI workloads like the large scale natural language processing and natural language understanding, where the way that giant cluster accesses data lends itself more to the parallel file system because it's capable of distributing that load a little better. So there's a couple of options here. I'm gonna keep moving on in the interest of time. NVIDIA and the AI ready platform, right? So you're probably familiar with NVIDIA's NGC suite is the whole software stack of all the kind of pre-built containers, models, software toolkits and everything. The whole idea of the AI ready enterprise platform is, like I said, customers have existing VMware estates. They know how to operate them. They know how to optimize them. All we really need to do is get some GPUs in there and they can start taking advantage of that platform for AI development. NVIDIA basically makes it super easy to pile all of that other software that used to only run on top of a DGX on top of any virtual machine that has got a GPU in it so that it can enable users at a much smaller scale. And of course, this really lends itself to the notion that there's a lot of customers who don't want to make that big investment, but want to see if they can reap some benefit from AI. And the AI ready enterprise platform, that's a mouthful. I can't say it enough. Really provides a nice roadmap to get there, right? It really enables all of those software capabilities without having the massive investment in the infrastructure. Max talked a little bit about cloud AI. I'm really only going to point this out. This is kind of an example of a validation. We've got several workflow validations where we tested this. We offer basically the same cloud services in all of the major hyperscalers, so customers can use whatever compute they would like to use, but still take advantage of a lot of the Netapp features. And to be clear, on ANF and on was it Amazon FSx for Netapp Ontap, that data science toolkit integration all does work, right? It's all exactly the same Ontap under the cover, so all of those same calls work together. One last thing. I don't know if anybody is familiar with GPU direct storage. The one thing I want to point out, we're the only vendor who supports it on 2 platforms. Both our Ontap systems support it and that E-Series system with BGFS. We had to do a little development work with ThinkPark to actually get that code into the BGFS, but that has been released and is GA. And then on Ontap, we can support GDS using NFS over RDMA starting in Ontap 9.10. And then we've got some more features and enhancements that are coming on in the next version. So that's it for me. I'm going to hand it over to Adam. I just wanted to emphasize that, you know, we've got this range of solutions across any of the deployment options a customer may have that all kind of tie into the capabilities of the data fabric and the data movement that we've been talking about. All right, thanks, Adam. Sorry.
Hello, everyone. My name's Adam Tettleman, and I am a product architect from Nvidia. So I'm going to talk today about Base Command and the Nvidia DGX Foundry, which are 2 programs that are sort of new, and we're going to market partnering very closely with DGX Foundry. So I'm going to touch on that at the end. But a lot of what I'm going to talk about today builds off of what Mike started off with around the MLOps layer, and then what we talked about with Max at the data science, what you're actually doing, and then I want to talk a little bit more about what David just brought up with all of these different stacks. So I'm a product architect, and I've had a lot of interactions with customers, helping them build out a lot of custom solutions or deploying third-party softwares or full stack solutions. And a lot of the times it starts off with a POC. And it's, you know, I want to set up Kubeflow and I want to just see how this works. But where I've seen a lot of people have trouble is when you're actually trying to build something that's not a POC and you want an enterprise-ready AI stack. And so you would think I'll just get the MLOps layer, I'll have my storage solution, I get something to hook them together, and I'm good to go. But it's never that easy, and when you jump into it thinking it will be that easy, you run into problems. So Base Command was NVIDIA's solution for this as a platform. And so I'm gonna back up a little bit and talk about how NVIDIA is an AI company. So most people, they know NVIDIA makes GPUs, and most data scientists know that NVIDIA makes SDKs, platforms, but we build a lot of AI within NVIDIA as well. We have our consumer products, we have our enterprise products, and we have natural language processing models that we build. We have super resolution, denoising, style transfer models that we build in-house for our products or with some of our partners. And we've been doing this for years now. And all of the issues that we talked about today, they're all issues that internally as a company we've had to solve. We've struggled with them, and this is that story. So we started less than a decade ago with our first server, the DGX1. And shortly after that, we launched Saturn V. We announced that it was our internal supercomputer, and it was a top 500 system. Over time, we've played around with the software stack internally. We've made a lot of mistakes. We've learned a lot of lessons, and we figured out how to scale up the hardware, how to scale up the cluster, but then also how to interface the software into that. And so it's been a long story. We played with OpenStack, we played with Kubernetes, and we played with Slurm, and we have a few different clusters internally. But what we've ended up doing is we've centralized everything. We've built our AI center of excellence within the company. And all of those products I just shown today, this is what we use internally at NVIDIA to build this. And so what is Saturn V, which is our internal AI supercomputer? We've got massive amount of nodes. We have millions of training jobs that we have run, and we have thousands of data scientists using this on a daily basis. We have AI researchers, we have interns, everyone in between is using this platform, and we're able to enable all of the different types of AI workloads within the same ecosystem. So we found it really useful internally. I know I was really excited when I got onboarded to it at first a few years ago. And we're now externalizing it and making it available as a product.
So So the Nvidia Saturn V is A100 GPUs, or is it Hopper?
So it's a mix. So right now it's A100, and I think that there's a white paper out there that has more details. But Saturn V is less of a single cluster, and it's more of an evolving cluster. So this is sort of where we put our new hardware, and we're able to, over time, and this is actually one of the great things about Foundry, is over time we can put new things in there and enable it at the software layer without having an impact on the data scientists that are using it.
So how much data storage are you sitting on at Saturn V, and what kind of storage is it? Is it the E series, or is it the Ontap series?
So for Saturn V specifically, I don't know the details for that, but we can share the details around the DGX Foundry. So some of Saturn V, the specs, it's our internal cluster, so I can't necessarily talk to that, but we have a mix of different things.
Okay. You mentioned 2 million AI training jobs.
Yep.
Is that like over the course of an hour, or a course of like?
So I think that's over the course of, I think, a year.
A year.
But you go in there, and it depends on what you're doing, because some of those training jobs are hyperparameter optimization searches where you kick off 100 jobs and they run for 30 minutes. Some of them are 500 node big NLP jobs that run for 2 weeks and train a massive model. So it's kind of a vanity metric, but the cool thing is it's everything in between.
Those jobs that run for weeks, you're checkpointing on a periodic basis.
Yep.
So you don't lose data.
Yep. And so at the software level, that's a really important point. We need to make that easy for data scientists to do. And I think going back to what we said earlier on in the day, they shouldn't know how to do a snapshot. They shouldn't know like what's running underneath. That sort of information, that level of detail, needs to be transparent to the data scientist, because they want to write Python code and they want to write a TensorFlow checkpoint, and they shouldn't care how it gets implemented under the hood. And so when I go back to that conversation around how do I build an enterprise AI platform, what's the easiest way to do training and development for my company? A lot of the times, I've seen way too many customers start off with Kubeflow and they think, I'm just going to do that. But then when they start getting into the weeds of it, they run into issues where, okay, Kubeflow gets me a Jupyter notebook and it can do this. But when I start getting into that, it's difficult to do checkpointing, or I don't know how the storage is managed. The Kubernetes layer underneath, do I do OpenShift? Do I do Rancher? Do I do upstream? Do I do a specific version? Do I go on the bleeding edge? There's a lot of conversations that come up, and there's never a right answer, because there are pros and cons to all of this. And then even at the bottom level, do I want a DGX pod with Ontap Ai? Do I want a super pod? Do I want something in between? So those are all table stakes. But when you're really getting into enterprise, you have to worry about the things like, who has access to this data? When I am doing checkpointing, what's the governance around that? Do I have single sign-on enabled? Like a lot of these boring enterprise features, things around validation and the legal aspect that your data scientist doing a POC isn't thinking of, that needs to be built into your platform, or you're not going to be able to go to market with it. And then on the other side, when you do go into the development teams, they do most of the times want more than just a Jupyter notebook. That Kubeflow and Jupyter and a lot of that baseline is really good, but eventually they're going to want more advanced features, and you're going to need to build those into the platform. So things like hyperparameter optimization, things like scaling out workloads from one GPU to multiple nodes, things like getting access to the latest hardware. You need to future-proof yourself on that, otherwise your platform will stagnate. So these are all like really common problems. Nothing here is unique to Nvidia. Nothing here is unique to Netapp. These are just the problems that if you want to build an enterprise AI platform, you need to keep all of this stuff in mind. And those boxes on the side are often forgotten about. And so this is sort of where NVIDIA Base Command Platform comes in. So that is our software layer. It has a cloud-based control plane. So you can go to ngc.nvidia.com, and there's a base command button, and you can submit your jobs. You can manage your your clusters, manage your data sets, and sort of see everything running in your environment through this platform. It's the common platform that we use within NVIDIA. We have all of those thousands of users using it. And it has the table stakes, and it has all of these additional features. So I want to dive into a few more of these features, because I think from the data science side, my background's more in data science, I think some of the stuff we do is really cool. And not just the stuff we do today, but how quickly we've been pumping out new features and new capabilities into this. So we talked about some of the HPC customers who want Slurm and they want a parallel file system. Well, we can enable those customers with things that are similar to Slurm. So SBatch, SRun, we have compatible CLIs and interfaces built into this platform to enable them. We talked a little bit about, I think Max talked about Rapids. So we have Rapids containers and things like that built in. So if you're a Rapids workshop, if you're a TensorFlow or a PyTorch, we have validated optimized containers for all of these different teams built in. If you are doing multi-node training, we have support sort of out of the box for multiple different types. So you don't have to go in and configure MPI. You don't have to go in and rewrite all of your code to use our specific multi-node launcher. We try to support all of them. Then of course, a lot of people have third-party tools that they want to use, and we enable those. A few of the partners listed here. And so, again, some of those are the baselines, but the important thing there is that as you're building up your enterprise AI platforms, you're not just dealing with that one guy on that one team. You're dealing with multiple people across multiple teams, maybe even across multiple orgs. And so the storage needs to support it. The compute needs to support it, but you also need to meet all of those teams where they are. Once you've met those teams where they are with the tools they're already using, then you can start building it up. So a lot of people use TensorBoard built into the platform. We also have support for profiling. So more advanced profiling techniques using Insight, using telemetry from the storage system.
The DGX Foundry is a SaaS service that anybody could use,
yes,
and that sort of thing. The base command is software that anybody could use, or it's integral to the Foundry, and it's how you manage the Foundry. But is this something that, I as a user of an AI space, I could go and say, I want to use base command as my MLOps tool?
So not yet. So let me jump ahead 2 slides. So this is sort of where we are today. So we have DGX Foundry, which is a managed hardware solution. And we have SuperPod, which is our reference architecture. Today, if you want access to base command, you can buy it with your SuperPod. So when you deploy your SuperPod, you're actually running all of your workloads through the software stack. Or you can get access to a Foundry, and the way you consume a Foundry subscription is through base command. We're hoping to make this more accessible in the future, but this is what we have now. And you can get trial access to it through a program called Nvidia Launchpad. So if you go to the Launchpad website, there's a trial link, and you can sign up and get access to the software and see how it all works.
And all the, you had a slide earlier where Nvidia had various solutions, Maxine, DLSS, and those sorts of things. Are they in the Foundry available, or is that something? I mean,
yeah, so that's a good question. So the products that I was showing were actually products. So like DLSS, that's how we do super resolution. That's a consumer. Maxine, that's more of something you would integrate into your application. 4 or 5
solutions there, right?
Yeah, but so we have other things like Tau, which is our transfer learning program, and things like that. And those are being built into the platform. And so
they're available with Foundry. You could go out and use Foundry to access those models.
Yes. So there's models that are built in. There's containers like the Trident container that's built in. And as we build out new platforms, and this is sort of one of the values of both Foundry and Base Command, as we're building out new things within NVIDIA, we first get exposure for those new tools internally in our sort of alpha clusters, but then we push it out to Base Command that anyone has access to. So it's really, on the hardware side, Foundry is the fastest way to get access to the new NVIDIA hardware, because we put it there so that you can get access to it before it's widely available. And then on the software side, base command is the fastest way to get access to all of the new tooling. Okay. So yeah, so closing up on the sort of the data science features, some of the new, more advanced things we're looking at is how do we build easy hyperparameter optimization, auto ML, transfer learning with Tower, all of these new platforms that make it easier to do maybe vertical specific things, machine learning, healthcare. How do we make that more easily available? And so a lot of that is available today through containers, but shows up in NGC and base command as soon as it can. And on the flip side, maybe the more boring side, but possibly the more important side, are the enterprise requirements. So I'm talking about all of these containers on the back end with Foundry and base command. We do a lot of security. So we've got monthly security scans of all of the containers we have in the container registry, alerting and notifications and updates if CVEs and things like that come out. So that's really important that enterprises have something like that in place. Also, a single pane of glass, super important. So if you've got thousands of users, thousands of jobs going on at a time, you need to be able to see not only what team is doing what, who's doing what, but also is my cluster being utilized efficiently? Do I have a lot of idle jobs that aren't consuming the storage or the bandwidth or the compute they've been given? Do I have jobs that aren't using tensor cores? Do I have jobs that are maybe doing too much work and it's a team that is over their quota and I need to go talk to that team? So these are all problems that once you have your enterprise AI cluster, you start dealing with these problems, and some of them can be really difficult if you didn't think about them going into it. So base command provides that. And then a lot of accessibility features. So we talked, I think, a little bit about MLOps and pipelining. So of course you need capabilities to do that. For the hardcore Linux people, they're not going to want to touch a GUI. So we give them a CLI and an API to consume. And then for maybe the people who are in the opposite camp, they don't want to touch CLI. Everything should be doable through a GUI. So lots of flexibility. And similar, you want flexibility from the hardware point too. So if you have a small workload that needs only a CPU, you can use that, and you're not consuming a whole GPU for every single thing. And then of course, support having both in base command and in DGX Foundry, Nvidia can act as a central person to come in and support. So we've got Netapp supporting us in the back end for the storage, but as a Foundry customer, there's sort of one choke point there. Like I said, Launchpad if you want to try it, SuperPod if you want to buy it, and Foundry if you want to get going right away. And so how do you make that decision, right? So I think David touched upon this in his slides around how do I want a DGX pod or do I want a super pod? But here are some of the things you need to think about, right? So does your company have DevOps, MLOps capabilities? Can you stand something up internally, even if it's a reference architecture and a super pod you're using? You're still going to need to manage it. So can you do that? Do you need it for a year, 2 years, 3 months? How much resourcing do you need? And should that be OpEx? Should that be CapEx?
So with the amount of data that we're talking about,
yep.
How does that stuff get in and out of Foundry quickly? I mean,
yeah, so we have some data connectors built, but this is a real problem, and it's
got to be. Right?
It's something that we're doing a lot of work right now to make it better. We're thinking about things like streaming from an external source and having the data platform work. But right now, I think with Foundry, it's really use case driven. So I think we talked about the big NLP customer earlier, and sort of what they did was they imported all of the data and then it stayed there. And so what this becomes is, if the use case you're doing fits what we have with Foundry now, you can get started in days and weeks instead of months. If not, we can bring the compute to your storage by deploying a superpod. So the beauty of the superpod is it's a reference architecture, so it doesn't take years and months. It takes maybe months or weeks to deploy. And then Foundry is days or weeks. So it's really workload dependent. So the easiest thing, if you don't have petabytes of data that you need to stream directly to the system to do your training, DGX Foundry is right now like the fastest, simplest turnkey solution you can get. It's based off of the SuperPod reference architecture. So you're going to get the same level of performance that we get in Saturn V and SuperPod, and you're going to get about the same level of performance in your DGX Foundry environment. And it's 24/7 support and SLAs and all of the things that the enterprise folks would need with all of those things that the data scientist is going to want that I talked about. And so what is it exactly? It's a SuperPod-based architecture where we have every customer that comes into a DGX Foundry has their own dedicated storage fabric, their own dedicated storage, and dedicated compute. It's available on a monthly basis. So you can get starting at 1 DGX all the way up to, I think, 20.
What about locations, Adam? So, I mean, a lot of this, you know, the governance and all that stuff require data not to move outside of countries. And
yep. So today we have those geos available, and we are currently looking at expanding. So today it's Silicon Valley and Washington, D.C. We have DGX Foundry environments that we're planning to deploy right now in South Korea, Germany, and Taiwan. And I'm sure there'll be more in the roadmap soon enough. But yeah, because that's a huge issue, right? You've got your data, and a lot of it needs to be compliant to multiple different standards. It needs to stay within the country of origin. And so right now, a big part of this DGX Foundry rollout is figuring that out and putting the clusters where they need to be. And if you don't fit in that, right, maybe Foundry doesn't work, and then you go with a SuperPod architecture. But you can vet it in Foundry. So that's sort of one of the selling points here is if you have a SuperPod and you need more compute for a short time period, data allowing, you can expand out to Foundry. Or if you don't want to commit to buying a full supercomputer and you just want to vet the process, you can use Foundry sort of as a staging ground to get your processes set up while you deploy a SuperPod. And the beauty behind that is the software level is the same. So from your data scientist point of view, they've got a drop down that says DGX Foundry Environment 1 or SuperPod Environment 1, but all of the other workflow that they would have to learn is the same. So all of the hardware, the geo, the compliance, how the data is moved, how the data is transferred, none of that makes it way up to the data scientist. It's all taken care of by the infrastructure, by the managed services, and by the software automation. So one more thing I just want to touch on, and then I'm going to jump to a quick demo if I can. So David gave a really good overview of the storage fabric, and I think there were some questions around the 140 nodes. So with this is the SuperPod architecture. So the DGX Foundry is based off of this, and this is the compute fabric. So we've split the compute fabric and the storage fabric such that they're distinct. And what we have here is each SU has 20 nodes into it, and that's connected to an IB switch, a spine switch for the compute. And then we have 7 of these SUs that are connected from the spine switches to the core switches, and each of these has 20 nodes. So we're able to get consistent performance within an SU and then near consistent performance across SUs using this topology. And right now with the switches we have available, this is as big as we can go, but we're always looking to expand this and grow this as new switch equipment comes in, new networking equipment comes in as the new generations of systems are available. And Foundry will become sort of the quickest way to get access to the cutting edge. So with that, let me, I had a 5-minute demo plan, but it doesn't seem like we'll have.
We only have about 1 minute and 20, so.
Yeah, so I can zoom through this real quick just to give you an idea of what the base command interface looks like. And so this is going to be completely driven from the GUI. So what we have here is I can create a workspace. So in base command, there's the object of workspaces, which, read write, and then you have data sets, which are read only. So I think this question came up earlier. like, how do we abstract this away from the customer? Well, we have a click button that says make a data set or make a workspace. So they don't have to know about what the CSI implementation is under the hood with Netapp, because all of the Foundry is powered by Netapp. They just need to see read-only. So when it gets to the point where you're creating a job, you sort of specify the environment that you want. So is that a Foundry? Is it a Launchpad? What's the compute requirement you need? Down here, you can see we have multiple data sets available. And so we have access controls on who has access to this data set, a person, a team, an org, or some are public. And you select the data set. You can see some of the metadata, and you just say where you want it to mount within your container. Also, you specify the results, and the results of your training job will end up read-only at the end, and that sort of gives you the full traceability across your data, across your containers that you're selecting. So the runtime environment, the code used, the data sets used, and then the results are all sort of traceable within the platform, sort of like how Mike was talking about earlier. I think we're at time. Should I? So this is sort of the UI. So I think you get a feel for it. And that sort of concludes everything I had to talk about. So I think, Dave, do you want to close out or? Yeah. Okay, thank you very much.
All right, thank you very much. Well, we have a rule here at Field Day that whenever you run out of time, that means you did good. So thank you very much. We are going to continue the conversation with Netapp off camera. But for those of you joining the live video stream, thank you so much for joining us. This has been a really interesting presentation. It answered the question that I had at the beginning, which is exactly where Netapp fits into the overall AI environment. And I particularly am happy, Adam, that you could join us from Nvidia as well. It's always great to have others join the conversation at Field Day presentations. If you missed any of this session or any of the sessions at AI Field Day, you can go to LinkedIn, go to the Tech Field Day page there, and you'll find a video recording instantly as soon as the sessions are done, where you can catch up on anything you might have missed. Also, all of these presentations would be available on the Tech Field Day YouTube channel. Just go to YouTube/TechFieldDay, click subscribe along with 42,000 of your best friends, and you can get some updates on Tech Field Day presentations there. And of course, you can also go to the Tech Field Day website and join our mailing list, which will promise no spam. We just send you an email whenever there's a Field Day event coming up to let you know what's going on. That's it. So thank you for joining us. We will return, how long, Rachel? In an hour and a half with a really interesting community contribution here about ML Commons. So do tune in for that. But for now, I think we're going to have some a little break and have some lunch here in beautiful California. So let's take the stream down.